All right, so what we're going to talk about today is translation. So we are talking about going from the language of nucleotides in our mRNA to the language of amino acids. So what I have here, so what happens is this is our piece of mRNA here, and it leaves the nucleus. So it leaves the nucleus and it's in our cytoplasm. And it comes over here and it binds to the small ribosomal subunit with the E, P, and A sites. All right, and the mRNA moves along until the start codon is in the P site. So it binds at first here, AGC is in the P site. So then it scooches along, GCU is in the start site, and remember we're looking for AUG, that's our start codon. Moves along again, UAU, moves along again. Oh, okay, there's AUG. AUG is now in our start site. So once that happens, our first tRNA can come, our initiator tRNA. So if AUG is in our start site, then our initiator tRNA is going to have the anticodon to that, which would be UAC. So our tRNA comes over and binds, and he's got his little amino acid with him and his anticodon there. Once he binds, then our large ribosomal subunit can come and bind. And this is our translation initiation complex. All right. So we have AUG here in our P site. In our A site, we have CGU. CGU is our next codon on our mRNA. So CGU is on the mRNA. So what is complementary to that is going to be GCA. So we're going to need to find GCA. So our anticodon GCA is this little incredible Hulk here. So here he comes, and he's got his amino acid, which is that Lego. So now what's going to happen is a peptide bond is going to form between these guys, and everybody is going to scooch down. So the mRNA is going to scooch down. These guys are going to scooch. The peptide is now attached to him. This guy doesn't have any peptide on him anymore. And this guy is in the E site, the exit site. So he can exit. And we have a new codon here in our A site. So in our A site, we have ACC. So what we're going to have to find is UGG. That would be the anticodon. So that's going to be this guy here, and he's got his Lego, okay? So now what's going to happen is the peptide bond will form. It'll be attached to this guy, and then everybody's going to scoot down one. All right, so this was ACC in our P site here. So now we have AGG. So our anticodon for AGG is going to be UC. So our tRNA that has the anticodon of UCC comes in with his little Lego, which is his amino acid. This one leaves the exit site. Our peptide bond is formed. And then everybody scooches down one. So now our AGG is in our P site, our peptide bond formation site, and the amino acid is attached to him. In our A site, we have CAU. So CAU, if that's what's on our mRNA, what's going to be our anticodon is going to be GUA. So that's this little Pokemon here. Okay. So he comes over and binds, and he has his amino acid on his head. This guy can now leave, and then our peptide bond is going to form, and everybody's going to scooch down one. All right, so our protein's on there. So now in our A site, we have CAA. So our anticodon for CAA is going to be GUU. Sorry, my ribosome's kind of falling apart here. So that's this little Paw Patrol guy. He comes with his amino acid on his head. So this guy is an exit site. He's now going to leave. The peptide bond is going to be formed. And then everybody's going to scooch down one. This is CAA. All right, now in our A site, we have GGU. So our anticodon for that is going to be CCA. So that's this little Pokemon Fox guy. He's going to come there with his amino acid. Now this guy's going to leave. Our peptide bond will be formed, and everybody's going to scooch down. All right, so now on our A site, we have UGA. So UGA is one of those special special codons that does not code for an amino acid or a tRNA. It codes for a release factor. So what comes in here to bind is a release factor. That's this little girl. Okay. This release factor, there is no peptide or no amino acid on her head. So remember, this guy's going to leave. And then the next step we would have is this making a peptide bond here to the next amino acid. But there's no amino acid here. So when everybody goes to move and we go to make the peptide bond, there's nothing to make it to, so it just floats away. There, our protein floats away. Everybody scoots down. This guy can exit, and now nothing is holding the ribosome together anymore. So all of our pieces float away. This mRNA can now go get translated by another ribosome, and we have our amino acid chain here. Remember, our tRNAs can go to their specific enzyme and get another amino acid added to their head so they can participate again. Our mRNA will be translated as long as it is stable in the cell and doesn't get broken down. And our ribosome can go attach to another piece of mRNA. The thing we want to remember is this, our amino acid chain, although a lot of times we like to say DNA to RNA to protein, we know that sometimes this amino acid chain is not a completely functional protein at this point. It may have to have quaternary structure where it complexes with other amino acid chains, or may need to be modified to become a completely, fully functional protein. But that's the process of translation. I hope you guys liked it.